Autodesk Civil 3D offers a complete drafting and layout toolset for pipe networks. Using a catalog-based part system, we can create, edit, and share pipe networks for gravity, storm, and sanitary systems in plan, profile, and section. This interactive and dynamic behavior is integrated into Civil 3D's environment, giving us the same control and layout behavior as seen with alignments, profiles, and corridors. We define the name, type, and description for the pipe network, as well as the surface and alignment it references for design before we lay out the parts. Using the layout toolbar, we can choose from a list of predefined structures and pipes and begin to create our network by selecting points in the drawing. As we lay out the network, both structures and pipes are created that follow predefined rules for design. These parts are created in plan, but a 3D model is built that references the surface and applies the slope, cover, and sump rules. We also have different layout options for creating curved and straight pipe, and being able to switch to different parts as we continue to lay out the network. Once the network is created, we can use grip edits to make adjustments to the planned location of parts, and because it is an intelligent network, all parts, in this case the 3 pipes, update with the change. The intelligent model also extends to labels. As we add a structure label, we see a lot of information can be added and stylized according to the label style. These meet our company or local standards. As edits are made to the network again, we see all the annotation update as well, eliminating costly errors or omissions and reducing the amount of manual drafting needed when the network is changed. With the network laid out in plan, we can quickly add it to our profile to see if any adjustments are needed for the rest of the design. If changes are made to the network again, like moving a lateral structure, the graphics update in plan, profile, and section as well, and any annotation that's been added to the network would update with it. Next, we will take a look at a typical scenario where we have 2 pipe networks in a design and need to find out if they interfere with each other. Since we are working with the intelligent models, we can run an interference check on these systems and display if and where the clash may happen. We run the check and pick the 2 networks we wish to analyze. The check will create an interference object in our drawing for a 2D clash, but we can also define a 3D proximity check to see if there's a problem in the Z elevation. Once the networks are analyzed, we get a notification of how many interferences were found, and an object is created in the drawing representing that interference. As we can see, we do have an interference and can zoom directly to the problem area in our drawing. By selecting the parts in question and looking at them in 3D, we see that not only do the pipes cross each other in plan, but that the sewer pipe is actually running through the top half of the drainage pipe. With this analysis, we can make the appropriate modifications to the interfering pipe to eliminate the problem. Here we will edit the properties of the sewer pipe and drop the inverts to clear the drainage pipe. With the model updated, we run the interference check again and can see that the problem has been fixed and that no more interferences were found. The pipe drafting and layout tools in Civil 3D adhere to the model-based environment where changes are made to the design are updated throughout the model dynamically. This system allows us to be much more productive by reducing the amount of time spent on manual drafting and allows us to explore more design iterations in what-if scenarios. This also has a benefit to our clients in the form of better designs and a benefit to our firm in the form of more projects and more money.